inequalities. It's not something to be scared of. These are just the alligator mouths that you're used to seeing in elementary school. 2 is less than 4. We know how to read that. The alligator's opening wide to eat the 4 because it's bigger than the 2. We know that. So 2 is less than 4. We can put variables into these inequalities now. We can say that any number y, an unknown number y, is greater than or equal to 7. So we know that it could be bigger than 7, or at least it's 7, but it won't be, it will not be like this. It won't be like -6, or it won't be 5, or it won't be 4. It's got to be bigger than 7, or at least equal to 7. And there's more than one number that can make this inequality true, because here we've got an unknown number, and there's more than one number that makes it true, because 8 is greater than or equal to 7. We know that 9 is greater than or equal to 7. I know that 7.5 is greater than or equal to 7. So we've got all these possibilities that could be there. And so as a result, if I said, could you please graph all of the solutions because it takes too long to write them, could you just graph them? We'd say, well, sure, that's no problem. We'd get a number line set up here, and we would say, well, let's see, y is greater than 7. I'm going to graph this one first, and then we'll take care of this inequality down here. Y is greater than 7. Well, I know it could be 7, so I'll put a dot right there. It could be 7, and then I'm actually going to go and shade in the direction that shows all the numbers that it could be, and I'm going to use a highlighter because it's easier to do on this pad. There we go. So from 7 on up, that would include anything between 7 and 8, 8 itself between 8 and 9. It includes all of these numbers that are bigger than 7. And because I put a closed dot on there, that would include the 7 also. So that's how I would do that. If I said, could you please go and graph x being greater than 4? Well, we need to stop and ponder this for just a moment. And essentially it would be this. What numbers could I plug in here to make it true? 5 is greater than 4. 6 is greater than 4. So I know that's the numbers that I want to show. But what about 4? If I put 4 in here and I said 4 was greater than 4, that would be false. That would not make any sense because they're actually equal to each other. And there's no little equal sign that's underneath the inequality part there. So we know that it's got to be bigger than 4. It can't be 4. It has to be bigger than 4. Now, when we were graphing y is greater than or equal to 7, we put a solid dot right on 7 to say that that's included with it. But the problem is I don't want to include this 4 because 4 is not greater than 4. I don't want to include 4. There's no equal sign underneath there. So what we do is we leave it as an open circle or an open dot. And so we put it right on the line and we just make it open. And then we shade all the other numbers that make it true. I don't want to go on 3 because 3 is definitely not greater than 4. I want to start over here with the 5. On this side, I'm going to shade to the end of my number line. There we go. And that has graphed all the solutions for x is greater than 4. So look at it this way. There's 4.5, there's 4 1/10, there's 5, 6. All of these numbers are bigger than 4. But I left this dot open to show that 4 is not what I want as part of the solution. Let's come on down and take a look at this one. We're going to graph the solution for y. Is less than or equal to -3. So we go to where -3 is on the number line, and I put my dot there, and then I have to stop and think, do I want it to be open dot or closed dot? Well, this has an equal to sign. That means that it's okay for my y to actually be -3. So I want to include -3 as one of my answers because this is okay because of that equal sign underneath it. Now, what's less than -3? It's not -2, it's not 1, 0, 1, or 2. Look at the larger numbers. 10 is definitely bigger than -3. And I want to get the ones that are less than -3. So I just have to shade the other way on my number line. And if you've got a pencil, you just try to darken in that line as best you can. So the basic rule is this. In fact, let me get rid of this to kind of make it a little easier to see. When you're looking at inequality signs that are uh, greater than or less than, you draw the inequality sign, and that would be the same as you do an open dot. You just draw the dot, just circle that in. But when we're talking about greater than, less than, or equal to, and whatever inequality signs have the equal to part, you draw the dot and then you go ahead and you shade that in also. And so it's like an extra part. So anytime that you see an open dot, you know it's talking about less than or greater than. Anytime you see that dot shaded in, it's going to be considered less than or equal to or greater than or equal to. And that's just a code that you have to get used to. Let's take a look at a couple of practice problems just real quick. We'll make a multiple choice, make it a little bit easier for you. So here we go. N is less than 1. Because I know that we're using the less than and it does not have the equal sign, it means it has to be an open dot. And so as a result, I know that it cannot be A because it's got a closed dot, and D because it's got a closed dot. N is less than 1, so any number less than 1 with an open dot is what we want. Well, this is negative 1, so it's not B. Here we are at C. Here's 1. It's an open dot because it's got the less than sign, and we just shade to the left to show all the numbers less than 1. Here's K is less than or equal to negative 2. Because it's got the less than or equal to sign, that means it will be a closed dot. Anything that's open we can immediately throw out, and it's kind of a nice little trick to show on multiple choice on these. Next up, we have to look at, well, what numbers being shaded are less than negative 2. Well, here's negative 2 and they're shading to the left. That's less than. Pretty sure that's the answer, but we check all our options. This isn't even negative 2, and in fact they're shading greater than 2, so it's not D. The answer would be C. Here's number 3. N is less than 4. Because it's less than and it doesn't have the equal to sign, it's going to be an open dot. So it's not B, and it's not D. N is less than 4. Well, here's a 4. I'm sorry, here's a 4, and 3, 2, 1, all of these are less than 4. It looks like it'll be A, but let's check here. The difference is that this is less than positive 4. This is negative 4. They've forgotten about all of these possible answers right here. See, because each one of these is less than positive 4, and that's why we have to go with A and say, sorry, C, you're not cutting it. Here's the last one I want to do with these, and then I'll show you one other trick. K is less than or equal to negative 5. Because it's got the equal to part on the inequality, it's got to be closed dot. So this time, that didn't get rid of any of the options. What's less than negative 5? Well, negative 6 and negative 7 is less than, so I'm going to put a dot right there and say that's probably it, but we'll come back and check it. This is positive 5, and that's greater than, so no. That's positive 5, and that is less than, but it's positive 5. Look, between here and here, these numbers right here are greater than negative 5, so that's why I have to say, no, it's not that. And here, negative 5, they've shaded the wrong way. They've got the dot in the correct spot, but this is bigger than negative 5, this is bigger. All of these are bigger than negative 5, so it's not D, it is A, just like we thought at the beginning. Now, the other thing I wanted to take just another moment to look at is the following. What if they actually give you the inequality already graphed and they just want you to write the inequality? So that's not too bad. Because it's open circle, anytime that it's open circle, we know it will be greater than or less than, depending on the shading. I'm always going to use X as the variable unless they tell me otherwise. Okay, so there's X. And let's see, there's 1, so I'm going to write positive 1 right here. They're saying I want all of the numbers that are bigger than 1. So X is going to be greater than 1. And basically that tells me right there that anytime that we're shading to the right of this point, it's going to be greater than the variable. Moving on down to the next one, and I'm going to scoot this back this way because my numbering's kind of out of place there. Let's just do this one. Let's see, X and that's -5. So here's -5. It's got a open circle, so it would be greater than or less than. And again, you can see all the numbers are greater than -5, so x is greater than -5. This time we've got a closed dot, which means, anytime we see that closed dot, it's going to be greater than equal to or less than equal to. So let's take a moment here and let's see x. This dot is on -2. And let's look at it. Let's see, -1 is bigger than -2. 2 is bigger than -2. 7 is definitely bigger than -2. So again, we've got a greater than sign, but because it's a closed dot, we put the equal sign. And now here we go. The very last one. And actually, I tell you what, let's get one that's a little different. I thought we had at least one less than. So let's just forget that this is graphed right here. We can forget that. Surely we can. And let's get a different one here. Let's get a nice closed dot here at -6. And let's have it shading down this way. Okay? It's hard to write with this. So we've got our variable. It's at -6, so let's write -6 right there. It's closed dot, which means it's got to be greater than equal to or less than equal to. It's got to be one of these two because that dot is cleared, is closed. We know that -6 is part of this. And -7 is less than -6. So anything that's less than -6 or equal to -6 will make this statement true.